This evening, we are going to discuss basically how to worry less with scoped CSS. My overall purpose in this discussion is to provide some ideas and suggestions about different ways of handling CSS in large projects especially, but it can also work for smaller projects as well. First things first, there are three main areas that we're going to cover. What is the overall problem that I'm referring to? Some techniques to potentially address this problem depending on your use case, and some closing thoughts as well. So basically, what is the problem that I want to discuss? I'm not sure you've had the pleasure, but in a lot of projects I've seen a single almighty style sheets folder. Some of you might actually know it. It's the place where all of the styling of the web application that you're working on are placed. Whether it's global styles for layout, for buttons, for typography, or application styles, that's where it's usually placed. There are different folders. Everything is very well structured. It's multi-layered. It's reusable. It's composable CSS rules. Now, why is this actually a problem? Sometimes it becomes really hard to identify the complete styling applied to a single DOM element. You have some font size in one file, but the color of the text is in a different file. And for some reason, you actually only need to change the color, and you've stumbled across the file where only the file size is defined, and you don't know where the color is. You need to find out. It becomes somewhat difficult. Obviously, this turns out to be more of an issue as the project grows, and it contains much more styling, style sheets, files, and whatnot. Also, because of the organization of these files, it's usually somewhat difficult to also change styling. The example I mentioned earlier, but there are obviously others that are quite relevant. And also because styles are spread throughout a set of files with some obvious reasoning to them, but not necessarily something that we already know, it can become hard to reuse. It's also a possibility that it's hard to reuse because they're really intertwined in a complex way. Sometimes it's actually even really hard to reproduce styling errors. For instance, I load a page, I see a bunch of styles there applied to some HTML elements. However, when I navigate to a second page where I would expect the same styles to be present, something different happens because they are actually rendered in a different context and some other style sheet rules apply as well. And these issues and some others as well could easily make us a little bit scared to actually remove any dead code and make some of the application a little bit cleaner. Why do these things happen? That's actually a very interesting question. There are a lot of ways we can actually end up in a situation like this. For starters, CSS on its own is technically speaking globalized in the sense that regardless of how you organize the files for the style sheets and regardless of how they are loaded in the browser, they will be globally applied. They basically have no isolation. There's also a potential problem sometimes with selector specificity. In this regard, I'm referring mostly to the fact that selectors have a way of defining how important they are in when rendering in the browser. And by using that selector specificity, the browser actually decides which of a set of CSS rules would end up being applied to a particular HTML element. These specificities are not usually hard to understand. Basically, they're a way the browser works with these. But the problem actually becomes more relevant when we're working with the same rule or similar rules defined across several several files. And how do you actually figure out which of those rules should end up being applied and which of those rules actually ends up being applied? There's also another issue with the overwriting property of CSS rules. It's somewhat implied from what I've already mentioned. Another aspect is that you can sometimes end with a lot of CSS classes defined on an HTML element in order to provide the complete styling for that element. There's one class that defines how the element is positioned in the page. There's another one that defines the typography of the element, and so on and so forth. These sometimes tend to provide the overall style of the single component that you're working with in a very, let's say, complex manner, or sometimes even convoluted. It is, in fact, considered general practice, especially when using CSS frameworks such as Bootstrap, but is something that can easily become hard to manage in time as well. There's also the other side of this aspect regarding the selectors that are defined in a CSS rule. You can say just a selector for a set of properties that you want to configure for a CSS rule, but you could also use several selectors. By using several, you usually tend to make things simpler with regards to what you actually write. The problem is that after that is written, it can really be more difficult to isolate just one, and it doesn't feel quite right. There are some solutions that I would consider partial solutions to these issues. And specifically, I'm referring to block element modifier, which is a methodology and a naming convention for writing CSS. This would be some HTML with the respective CSS classes for it. It's actually really nice and provides a lot of meaning to the HTML and to the styling as well. My problem with this approach is mostly around the complexity of the classes themselves. You have to write quite a bunch of classes in order to make something work in a sensible manner. There is another approach outside of BEM. There are obviously others as well, but the one that I'm referring to is object-oriented CSS. And in this one, basically, CSS is, let's say, multi-layered. You define some generic properties for customizing CSS in a way that makes it much more usable than other approaches, using basically object-oriented concepts. This one too provides a lot of meaning and reusability to the CSS that we're defining, to the styling of our web application. However, both BEM and OOCS both require some thorough thoughtfulness when working with them. You can't just write plain old CSS and have it to work. You have to understand what's going on, and you have to understand the reasoning behind that. You have to understand the abstractions that you're working with. That's not a bad thing to do. The only thing that is relevant is that sometimes you don't have that time available. You have to deliver in production something really fast that works and is okay as well. You can't just, I don't know, just do a hotfix with absolutely no quality in mind. But the problem is that when you're working in a hotfix mindset, let's say, things rarely tend to be as simple as one would expect. Okay. I see someone in the comments is saying that in general, it is good to understand what you are doing. Yes, that's obviously a must. It's impossible to do things without that. The problem for these two approaches, as I see it, is that it takes quite a significant amount of time to do that, sometimes at least. Sometimes it might be more time consuming to do this, especially if you don't know how to do it. It's much more common for some junior developer to know how to write CSS and HTML than it is what BEM is about and how it should be structured. That would be the overall point I'm trying to make. So with this in mind, what are the things that we would like? We'd like to have some form of isolated CSS scoped. We would also like to have a tighter coupling between our CSS, our HTML, and our JavaScript. To have this functionality acceptably usable for new joiners, to make it as easy as possible, to allow features to grow easily over time in a project, and to also have the project easy to use after we've put it on hold for a couple of months and it came back to life afterwards. Things like that do happen, and it's usually nice to have a fast way of getting back on track with that particular project. There are some preparations that I consider useful for this, although I'm sure there are others that would also work extremely effectively, extremely well. First things first, it's nice to have a better separation between the generic styles that should be available to all elements of the web application and styles that are specific to particular components, to particular HTML elements, functional features, and things of that sort. Obviously, try to simplify the CSS both for the generic and the features. The overall idea being that there are elements of typography, layouts, color theming, headings that usually are better off as defined as simple as possible within the context of the generic style sheets, the general purpose style sheets for the web application. There's no need to create overly complex, overly inclusive generic style sheets that take into account absolutely each and every possible scenario that could happen in the future. Another thing that, from what I've seen, makes my life at least easier is the use of feature folders, as they are called sometimes. Basically having the CSS, HTML, and JavaScript in a place together. In some scenarios, this is just a folder. In some scenarios, this is actually just in the same file. I've seen React actually do this a lot, or a lot of versions of React applications tend to have in a single file both HTML and CSS and JavaScript. Okay. There are a couple of techniques after we've finished our preparations that can actually help us with having a better encapsulation of CSS overall. Some of these techniques are compile time, some of these are runtime, in the sense that they are applied directly while running in the browser. And on the other hand, there are also some that are a combination between compile and runtime. Part of this solution is done ahead of delivering the files in the browser, and part is at runtime. These basically are ways of pre-processing HTML and CSS, CSS modules, CSS in JavaScript, and web components. These are the ones that I found. I'd actually be curious if you could let me know in the chat if there are any others that I've missed throughout the presentation. I'm always happy to find out more. So let's start with CSS modules. CSS modules is a hybrid approach in most scenarios. It involves a compile time stage and a runtime stage. At the compile time stage, the original CSS that we've written ourselves gets converted into isolated CSS. More or less, this is basically just some fancy things around our original one. This isolated CSS becomes injected at runtime in the browser, and then everybody is basically happy. That's the overall idea of it. It has its downsides. It has its pluses as well. The nice thing is that Webpack, which is a very popular build tool for front-end applications, has first-party support for this. But it can also be used without it in particular. You could actually have just a different library called PostCSS with an extension for it, PostCSS Modules. What this basically means is that with some preparation, it can be used throughout a lot of front-end oriented projects. Next, we're going to see a small example of this in action on this slide. Let's see here. So here is our style.css file, and we have just two CSS rules, one for a background and one for the color of two separate classes. In the main.js file, which would be loaded directly in the browser at runtime, we just import the styles using ES6. That would be the preferred way, but others are also available. And we would write our HTML template as being the one that works with the styles exported from this file. This is something that by default doesn't appear natural, at least it didn't to me when I first found out about it. Basically, the preprocessor, or in our case, Webpack, would in fact change what is imported from the original CSS file to a JavaScript object with some classes. In the browser, when the application is loaded, this would be the actual result that is loaded. We have the equivalent of the original CSS file. As you can see, there are some changes to the class names. Container from here gets converted to this container. And basically this is the whole concept behind it, that CSS preprocessor changes the names of the classes in a way that they won't interfere with each other at runtime. However, you also need to make sure that the original HTML, such as this one, actually uses the generated class names, which is why we create, in fact, an HTML template that at runtime will use the proper class names, which is the one that ends up here being rendered. And basically, that's the whole gist of how CSS modules work. It's a good trade-off between simplicity of use and, for instance, being able to reuse existing styles. If you want, you can create actually more general purpose style sheet elements as objects and import them in other projects as well. The next option is one that focuses entirely on the pre-processing. This is basically not a specific method in particular, but it's more of an idea, let's say, in the sense that there are plugins available as well but they're very specific to particular frameworks or particular formats of using this. Another option is that you could fairly easily, write your own custom plugin for a bundling tool to actually do some form of pre-processing. The main advantage over something like CSS modules is that it would only do compile time processing, and it can actually allow for no performance performance issue introduced at runtime, because it wouldn't do anything at runtime explicitly. Another very relevant aspect is that since it's not a particular solution in mind, just a concept, let's say, the plugins could be easily written for exactly what you have in your project, so that this technique would be somewhat more flexible with that in mind. It's quite often that we see Webpack-based front-end applications, or I'm not really sure right now if Grunt and Gulp are still used that much, but I do know they are tools that I've used and that are used on some projects. Regardless of the scenario, it might be that your current situation doesn't allow for something overly simple, let's say, the use of an existing tool. And by making your own tool for pre-processing CSS and HTML, you can go around this. How would that look with Webpack in particular? We have the same CSS file. We have the same HTML. In this type of scenario, things would be a little bit different in the JavaScript side. You would have to import both the style sheet and the HTML. What I'm highlighting is a little bit cut off, but I think it's visible. We would have to render the HTML on the page using something like this, and also for the style as well. Other options for creating the HTML from the template and injecting the style could also be applied, obviously, because it's plain JavaScript. The nice thing is that, for instance, with Webpack, we would basically have to develop two loaders, sorry. One would be for the CSS and another one for the HTML. Their purpose would be to make sure that what we reference is coupled together in at compile time. Their overall result would in fact be something similar to this. And the nice thing is that we wouldn't have to use any additional class-related references. As you can see, the HTML uses the original classes I've defined in the file. And this is an approach that would make using a form of isolated CSS in a heavily customized project much more flexible. It would make things even easier for others to use it as well, and there wouldn't be any significant impact on the knowledge base for the project, because you wouldn't need any extra knowledge to use this. You just need to define a regular CSS, a regular template, and use them in the JavaScript as well. Okay. Now, for something a little bit more interesting, we've said a little bit about compile-ready versions. There is also one option that is really interesting based on web components. Web components is actually a specification from the W3C consortium, and it's basically a standard in the browsers. Most browsers today support web components in general. And what web components brings to the table as a technology is that you are able to write completely isolated HTML elements with any sort of logic you want, as long as it's browser oriented. Basically, you provide your own HTML, JavaScript, and CSS. And by even using the shadow DOM, you can have the CSS be completely isolated. This can actually use also HTML templates and provide much more flexibility. The potentially relevant downside is that this is actually a runtime behavior, runtime functionality, in the sense that you load the definition of that particular web component, and at runtime, it will be rendered in the browser. The style sheet would end up being applied specifically to that component, and you would be able to see it at one point in time. There isn't a significantly large delay for this, but it is noticeable, and in some scenarios, it is really important to take into account. One aspect that is a little bit more relevant with regards to developing web components is that from the base specification that the browsers support, you end up with a lot of code that you need to define in order to set up a web component, which is why there are a couple of libraries out there that you could use if needed and if you prefer, that could help things along. Between these, I'd say that LitElement is the one I found a little bit more interesting, which is why we're going to look at a small example with it. In this example, we're using also ES6 to import some elements from this library called LitElement. We define JavaScript class called popupinfo, which extends LitElement. We define a way of returning styles using something really interesting that is a little bit new. And the same goes for the HTML as well. So these are template literals, and they help a lot with simplifying the syntax for defining CSS like this or HTML. Afterwards, we also have to register our component. And basically, this is the syntax to ensure that it won't get redefined at startup. Okay, and basically, this would be the HTML that would reference the element we've defined. This is the custom HTML tag for it. And the nice thing is that that's all the JavaScript you have to write to ensure you have an isolated component. The relevant aspect here would be that if it's possible for you to actually use a library such as LitElement or some others, it's a little bit easier to write the code to create an isolated component. However, it is not actually mandatory. It's something that is available in the browser by default without any other tooling necessary. So this works really well in scenarios where the existing code base might be extremely old, or where you don't actually have the rights or permissions, or or for other reasons, you can't actually add anything in that code base. So you could quite easily create new HTML components that are used in a very simple fashion just by referencing some custom HTML elements. And next up is, I think, one of the more debatable versions or techniques. It's something that, from what I've understood, is extremely popular with React, or I would actually say popular. I don't want to sound overly knowledgeable in React. I almost don't know anything about it. Okay, but with that out of the way, CSS in JS is mainly a runtime technique for isolating CSS and styles. as a technique in general, it's really nice because you can use it with JavaScript, any version of JavaScript, and with TypeScript as well. And it's actually writing JavaScript that styles the application. Obviously, you don't want to write it in any way whatsoever. You do need to have some form of API to be able to understand what's going on over there and to have something that is reusable as well. The nice part is that it also has complete integration with any existing JavaScript tooling because it is written in JavaScript. There are some libraries available as well. I'd say JSS and styled components. Styled components, from what I understand, is something strictly speaking for React. And from what I've seen, it's really cool. I'd rather discuss a little bit more about JSS, which is, it has also integration for React, but it also is framework agnostic by default. You could use it with whatever front-end technologies you prefer, or at least in theory. In general, let's say that's completely true. So with JSS, in plain JavaScript, you would actually import JSS and a preset for it. You would create a setup phase. Then you would define your styles as a JavaScript object. And you'd create a style sheet from that definition. Notice here the object that is defined here. And then we just use it in the page, like we've seen, for instance, with CSS modules as well. Basically, the creation of style sheets creates an object that defines the runtime version of every class that is defined in the, let's say, template styling object. And I'd say the most interesting part about this approach is that you can actually enable full reuse and logic from JavaScript to be implemented in the styling. There's no actual need for dynamic styling that is usually used with classes that are called active to represent the style of an active button. You could actually change the CSS that is being injected. Some consider this a good approach, some might not. It's a little bit debatable on depending on your project requirements or some other things as well. Okay, the next part we're going to discuss is a very short presentation of, well, not presentation, a short sentence about frameworks that are currently using forms of CSS isolation. The first one that I'd mention is Angular. It uses component styles as they name it. Component styles are actually a combination of CSS modules while using the shadow DOM. And they have their own technique about it, but it's actually a fairly good approach. From what I know, React on its own does not provide any sort of integration, but there are a lot of third-party or second-party libraries that offer extensive support for this. In the Create React app, there's, for instance, CSS module integration by default, and you can simply just use different naming convention for the files for CSS modules to be used. There is the styled components that I mentioned earlier that can be used for CSS in JS. And from what I've seen, there are quite a few libraries that support different versions of CSS isolation. Aside from that, there's also the Vue framework, which I'm sure is also quite popular, which also uses CSS modules. And something that I was actually quite happy to find out Blazor, which is the most hypest technology from Microsoft to date, is using CSS preprocessing as well. And from what I've seen, it does actually a fairly good job, actually. For the Angular aspect, I would like to discuss a little bit more. This is because their version, I think, as far as a framework is concerned, is the one that is the easiest to use by default. If you want to be sure that the project is easy to use by a wide set of developers with a wide set of experiences from the past, I think an approach similar to the one that Angular provides is actually the best of both worlds. So in general, what you can do with Angular is you create a custom Angular component, which is extremely fancy to create. You define the URL for an HTML file, which is the template, and also for the CSS. These are the files. They have absolutely nothing special. And afterwards, Angular at runtime would end up with something like this for the style. Notice some additional things here for the container class. And the same goes for the title. And also for the rendered HTML, this is what it looks like. And it uses something like this to ensure that classes don't clash for properties. Angular also uses the shadow DOM as well for this, and overall it makes things easy to use to some extent at least, and also fairly easy to work with for other purposes as well. But okay, we've talked about frameworks, very little I know, but we did talk about them. But what if we're not using a framework or we don't want to use a framework? Which approaches could we do? So for general purpose solutions, we could go with web components. We could use CSS in JS library, preferably a version that is not dependent on a particular framework. This is mostly because it would make things easier for the project in the future should some changes be needed. There's also integrations from bundlers like Webpack, Grunt, and others. Those would be the options that are mostly suited for generic applications that are not written in a particular framework. Or if the framework does not support CSS modules on its own. Very well about this. Next in line, I've presented a lot of things that I believe are cool and interesting. However, we do need to keep in mind that everything has something white and something black, something good and something bad. Let's talk a bit about trade-offs. As with every technology that we use, there are some things that are more or less, let's say, not nice. Some things that we'd like to avoid, but it's really important to know them, to research about them when trying to apply any technique, and to make sure that we have a clear picture of what we're getting ourselves into ahead of actually doing something about this, because as with most things in life, mistakes can cost. And these are some of the trade-offs that I'd like to discuss. Some would say that class names, because of different isolation techniques for CSS, can become really ugly and hard to understand, and make things look less usable. There are some arguments to this that are relevant in the sense that UI tests, for instance, sometimes rely heavily on class names to identify components. In those scenarios, UI tests will have to require some changes as well. Class names also could be used to define some more semantic to the application, or are also used to debug different scenarios. If the class names of an HTML component are generated each time you load the application or something like that, things might not be so easy to understand if you're using class names. There are different approaches to handling this. Sometimes you actually could go without using class names to do debugging. There are other ways to do that as well. Another concern at times is the fact that if every HTML component that we're writing is completely isolated from the rest, what stops us from writing duplicate code? Technically speaking, there's nothing stopping you. And to some extent, that is actually a good thing in the sense that you do have duplicate code, but you also have isolation. With isolation of that duplicate code, if something goes wrong, it will only happen in one place instead of the entire application. So that could actually be a good trade-off in some scenarios. Do you want a single button to look bad, or do you want all buttons in the application to look bad just because at some point somebody made a mistake? And developers are humans. Humans make mistakes. Everybody makes mistakes. So let's try to be reasonable about this and weigh our options. It's not something that happens, there's no single good approach to this, and it matters a lot how the project evolves, how the team that works around that project views things, and how they can organize as well. Another relevant trade-off is the fact that with third-party UI components, if they are also using CSS isolation, at times it can become difficult to do styling customizations on those components. And in a lot of scenarios, this is not as much of a problem as you'd expect. Although components are isolated, if you are using a different syntax, you can force those components to actually become stylized according to your approach. There's also, in a lot of scenarios, libraries that for their UI components provide additional customization options. They provide the actual style sheets for you to customize, or SAS files or LESS files or other approaches to enable more extensive customization. Unfortunately, these are not the only possible trade-offs. There are others as well. The one that I think you are already seeing is the runtime styling that at points can make your application work slower or provide somewhat less responsiveness, or even for a period of time have a flash of unstyled content. These sorts of issues should be taken into account from the start. They are not relevant for all of the techniques I've provided. And more than that, they are not always relevant for versions that do use runtime styling. There are scenarios where these do not happen because the styling that should be applied at runtime isn't overly complex, and it just makes things look better, not have a particular style, let's say. In scenarios where you do end up with the more complex styling of your application being applied at runtime, there are also other ways of resolving this. I'm talking about server-side rendering and preloading critical CSS. With server-side rendering, what you can actually do by using third-party tools, or in the case it is extremely needed, you could even implement something on your own. You could create a way of generating both HTML and CSS on the server and deliver that representation to the client as a way of enabling the user to see something faster in the browser. And while this is happening for the end user, in the background, the browser will complete loading the rest of the runtime styling and applying it. The other approach, by using critical CSS preloading, is almost the same, but it would be somewhat a less involved approach, in the sense that you would identify what CSS makes it so that the visual representation of the page is something desirable, or something that makes at least the application usable as a user experience. And identify that CSS and have it as statically loaded CSS. With that in mind, the rest of the more complex styling that is needed can be applied as with the server-side rendering at runtime in the usual manner. Those would pretty much be the trade-offs overall. And as a closing argument, I'd like to say that I hope you at least consider using scoped CSS in future projects or existing projects. Try as much as possible to reduce the global footprint of CSS. Think about the style sheets that you're writing and try to consider how much more simple you can make them. And with both of these two main thoughts, I hope you would be able to worry less about your CSS. Thank you very much. And later on, when the slides will be available, you will also be able to see these references better, which I've used for the presentation. So at this point, if there are any questions, and hopefully I'll be able to answer.
Yes, you do have 3 questions in the chat room.
So, okay.
From Gennady, the first one. Suppose you have a legacy project, no specific framework, you want to reduce CSS complexity. With what technique will you choose to start?
It depends a bit on how big the project is. If it's an extremely big project, but with no particular framework with it, the second part that would matter is the timing related to doing this. I think the simplest option, for me at least, would be to actually either use CSS modules or a pre-processing technique. The pre-processing technique would be the least intrusive one, because it basically wouldn't have to change any of the existing code, or the amount of existing code changed would be as little as possible. However, it wouldn't improve the quality of the code base in general, just the styling. So it depends a bit. Okay.
I have another one from Paul. Why would I use scoped CSS when I can have a parent class that can specify where the styles are applied?
Yeah, I think I don't understand entirely the question. Paul, do you mind explaining a bit more?
Sure. I was wondering what advantages are there to using scoped CSS when I can just write in front of the selector for my styles a class like my component. So use that as a parent selector. And then when I write my component, I just make the parent element be that class.
Your question would be, why should I have isolated CSS when I can just write this as a prefix selector for styling the H1?
Yes.
What would happen if before loading this element, there would be a selector that would say something like div space h1, and for that selector apply some the same background property.
I think that would be applied last.
That's my assumption as well. I'm trying to provide this as an example because it could be that some other elements on the overall loaded CSS could have the same specificity as the one that you've mentioned.
I see.
Or,
So it's to ensure the specificity isn't overridden by
yeah.
some other styles. Okay, that's clear. Thank you.
Welcome.
Okay, another question from Ketano. How would you start on converting an unscoped CSS project to a scoped one?
Well, first things first, I'd try to isolate components in that project as much as is possible. And then I'd try to figure out what is the relationship between those components and the generic CSS to make sure that also the generic CSS is properly separated. And basically from that point forward, piece by piece, just ensure that each feature, let's say, would be isolated using one of these techniques, depending on the nature of the project. Does that answer your question properly, Ketan?
Yep, that's good.
Great.
Okay, great. Moving on to the next question from Larissa. What is the option that you prefer the most, and what will be the technique that you choose for a new project?
So as far as practicality is concerned, I'd say that basically an option like the one that Angular provides, I see being the simplest one to use. Depending on the framework that is available to that particular project or that can be used, either I'll go with Angular because I already know Angular, or if it is possible, I'll try to figure out a simple way of having that available in the project. Aside from the practicality of it, I really like the version with web components, especially because they're much more reusable overall. So you could actually create a library from based on a web component and have it available on multiple front ends that were implemented with different frameworks or without any frameworks, and it would be ready to use regardless of where it is.
And another question from Claudio. Dan, you have presented a lot of useful information, but can you tell us what would be your favorite thing related to scope CSS?
That might sound a little bit silly for me to say, but I'd say it's the fact that I can worry a little bit less by using it. The thing is that personally, I was in a lot of scenarios really annoyed by the fact that it's hard to ensure that I can easily move one piece of HTML with its CSS in some other HTML context. So if I move one button from one container to another, or from some panel or something like that, in a lot of scenarios, additional CSS rules would end up being applied. That would make the button look completely different and not in the way I intended.
And Claudio answers, worry less, scope more. Thank you, Dan. And we have one more question from Paul. Can you make web components using a more complicated framework, like say Angular?
I don't know, but I think you can. I remember reading about some Angular components, I think they're called. But I'd rather keep my answer at that because I don't know anything more about this.